here to tell you about informed search strategies in artificial intelligence. Before going to start, I'm hopeful that you all have studied about uninformed searches, or you are familiarized with all the search strategies in uninformed searches. So if you are not familiarized with that, I'll try to figure out the difference between both. So basically, these are the contents which I'm going to cover in my PPT today. That is difference between both the searches, that is informed and the uninformed searches. What is all about informed searches, what are the heuristic function, how to calculate those functions, and best first searches, that is greedy first search. With an example, I'll try to explain all these things. And then A star search algorithm with the help of examples. So before going to start, I am going to tell about the difference of uninformed and informed searches. So basically, search is basically when I am searching from a start node to destination node. So there might be several paths to reach out from that start node to the destination node. So uninformed search says that before going to start or to reach out to the destination, I don't have any previous knowledge about how to reach to the destination. So basically, uninformed search is all about where there is there is neither any previous knowledge of the concept or knowledge about the path to be explored, or I don't know about the path cost, I don't know how to reach out to that path node. But in case of informed search, basically I have a previous knowledge or prior knowledge about where to start from, how to reach out, and what are the path cost of reaching from S to D, source to D. So basically I try to figure out these differences with the help of this table. So basically, uninformed search is basically the blind search, because as I've told you that I don't have any previous knowledge. So if I want to reach from source to destination node, so I have to explore all the paths. So in this way, because I am exploring all the paths, so this search is also known as a blind search. Whereas in the informed search, it is known as a heuristic search, because I have a previous knowledge about the path or the cost of the factors or the factors. So basically, it also known as a heuristic search. For this informed searches, I uses the knowledge for the searching procedures, and in case of uninformed searches, it basically does not use the knowledge of in the searching procedures as well. In case of performance, it guarantees to provide you the solution quickly, whereas in uninformed searches, it is slow as compared to the informed search. In case of completeness, it may or may not be complete. I'll explain how this concept is going to be formulated. And in this case, it is always complete because I am exploring all the paths. So it is a guarantee that I'll definitely going to reach out to my destination node, and what will be the best path for all this thing. That's why it is known to be complete in this. For in the factor of cost, it is considered to be low, it is considered to be high, because it is exploring all the paths, and in this it is exploring only the bestest path. Then in case of time, so it will be more quicker and it will be less quicker in that. And in case of implementation, it will be less lengthy, it will be more lengthy in comparison of efficiency. Efficiency will be calculated in the form of cost as well as performance. So when the performance of this thing is quicker and speed is higher and the cost is low, so efficiency of this algorithm is considered to be more in comparison to the uninformed searches. So these are the various examples of the algorithm which you have already studied about uninformed searches. That is, I must be hopeful that you are having a knowledge of DFS, BFS, branch and bound, UCS, that is uniform cost search, and iterative deepening and bidirectional searches. So these are the searches that we have already read in the previous slides or previous knowledge of all this. So I am going to discuss here the informed searches, and in this I am going to take up the greedy search as well as the A star algorithm. That is the most important algorithm in informed search. So basically, what do you mean by informed search? Informed search is also known as a heuristic search. So informed search is basically an algorithm that contains an array of knowledge, such as how far we are from the goal, path cost, and how to reach to that goal node. This knowledge helps the agents to explore less to the search space and find more efficiently the goal node. This algorithm is more useful when I am having a large search space. So in this algorithm, it uses the idea of heuristic. Heuristic is basically means the approximation to anything. Like if I want to reach out to some place, to some destination, I must have a previous knowledge and I must have a rough estimate to how to reach to that destination. So this is basically what is the idea of heuristic. So that is why it is also known as heuristic search. That means basically I can say that in this search, I try to solve the problem in minimum number of steps or minimum number of costs. So next is what is heuristic function, because as I have told you that this is a heuristic function. So basically what is heuristic and how it is to be calculated. So first question is, what is heuristic function? So heuristic function is basically a function that is used in informed searches, and it is represented with the help of HN. Okay. It calculates the cost of the optimal path between the pair of the state, and it finds the most promising solution. Why it is required? Because it helps us to decide quickly. It helps us to decide with the minimum amount of data, minimum data, and it also helps to make efficient decisions in this. In this case, in heuristic function, it takes the current state of the agent as an input, and it produces the estimation of how close is the agent from the goal state. So the heuristic method is, however, not always give the best solution, but it guarantees to give you the good solution. That is because, as I've told you, that I'm not going to explore all the paths. Heuristic function is basically say that out of all the paths which I am doing in the uninformed searches, that I am exploring all the path, which is a time consuming process. So instead of exploring all the path, I just move with those paths in which I am finding it suitable or in my favor, or some gains is to be incited in those paths. So that's why I can say that I'll always guarantee to give you the good solution, but may or may not be, it will be the bestest solution. So the next question is, what, why and how a heuristic function with the help of examples. So first question is, what is a heuristic function, which I have told you that this is heuristic function which is used to calculate the cost of an optimal path between the pair of the states. Then the question is why we need this. So why we need this can be easily understand with the help of a problem. If you have known about the traveling salesman problem. So traveling salesman problem says that if a salesman have to visit some cities, suppose there are 5 cities, and the person is you want to search all these spaces. So for reaching out to all these cities, the salesman have to visit all these 5 cities in all the approximate and possible combination. So in that case, it will give at least 5 minus 1, that means number of cities, yani n minus 1 number of possibilities or probabilities, or you can say the search spaces. If the state is increased up to 10, up to 100, up to 200, you can assume that it increases the number of search spaces. That means the complexity of the problem increases. In that case, this problem becomes a problem, and this can be solved in NP time, that means non-polynomial time. So solving a problem in NP time, non-polynomial time, is more complex. So I want to decompose my problem and to solve this problem in polynomial time, so that my time will be reserved and I can reduce the amount of effort that I'm doing over here. So I have to change this NP time into polynomial time. So for polynomial time changer, I need a function or approximate value about on a search, so that all these things can be done in a polynomial time, and I'll reserve my time for that thing. That is why this heuristic function is needed. So the question why this is needed, this is needed because to change the polynomial time, non-polynomial time to polynomial time, this is the reason behind it. Now the third question is how to calculate the heuristic function. So there can be various factors in which you can calculate the heuristic function. That is some real-time examples for this is, if I am driving, then how to find the shortest driving distance to a particular location. It can be used via Euclidean distance. Euclidean distance is basically, if I am saying that I am here and I have to reach to here, so there could be certain different paths for this, basically like this way, and I could reach to this destination node in any way, but I'll choose the path which is having the shortest distance. That means from this to this, I'll choose this path only. For here, I have two coordinates like x1, x2, and here suppose there is a coordinate x2 and y2. So for finding out the distance, formula says I have to find like x2 minus x1 whole square plus y2 minus y1 whole square. So in this way, I'll found a shortest distance, a shortest path distance from of this path, and I can calculate the Euclidean distance. Then second example is choosing between different brands of food items at the grocery store. Third could be an educated guess. That means you can make a guess according to your previous experiences. Rule of thumb can also be applied. That means that you are having some practical experience of anything. And last but not the least is the 8 puzzle problem, solving an 8 puzzle problem with the help of Manhattan distance, in which this is a kind of puzzle problem like this way ki I'm having a chessboard and that is having some kind of tile. There are 9 tiles, out of which 8 tiles are occupied, and this is a final state out of which I have to reach out here. That means what I have to do, I have to decide that I want to go from initial state to the final state. But if I take uninformed search, then I have to explore all the possible combination of this state to come up with the final state. But I'll not take the uninformed search. Instead, I'll use informed search, in which I'll use the heuristic. So heuristic will be, I can use the heuristic as number of misplaced tiles, as well as I can also say that if a tile has a limited movement of up, down, right and left, so I'll calculate the number of movements of each and every tile, and in this way I'll calculate the total sum of all the heuristic, and which heuristic is come out to be lowest, I'll choose that heuristic for my search. And this is how the heuristic function is calculated. So this is the reason what, why and how the heuristic function is needed for us. Then further, for this heuristic function, we need to apply these searches to the algorithm in the form of heuristic search, and that search is known to be pure heuristic search. In this search is basically I expand all the node based on the heuristic value, that is hn, and it maintains 2 lists, that is open and closed list. And all in this list and closed list, it places all the nodes in which already all the nodes are already expanded, and in the open list it places the nodes which have not been expanded. So in this on each iteration, I must use each node, and with the lowest heuristic value it is expanded, and it generates all its successors, and n is placed in the closed list. This algorithm continues until the goal state is found. So here in this informed searches, I am basically going to discuss the 2 main algorithms, that is best first search as well as the A-star algorithm. So the first is best first search. As the name indicates, the best means that out of all the paths, I'll select the path which appears to be the best at that particular moment. This search is also known as greedy search, because again, if that path appears to be the best, that means I am ignoring the path that could be efficient or that could be better than that, but because this path is best, so I am going for that particular path. So that is why it is also known as a greedy search. This search is basically the combination of DFS and BFS that we have previously studied in the uninformed searches. This uses a heuristic function in the search. This search allows to take the advantages of both the searches, that is DFS as well as the BFS. The greedy best search algorithm is implemented with the help of priority queue, because as I am choosing that this is the easiest, or this appears to be the best path, so that means I am assigning some kind of priority, and so if priority is there, so priority queue will be there to implement this kind of algorithm. So at each step we can choose the most promising node. In the best first search algorithm, it expands all the node which is closest to the node, and the closest cost is estimated with the help of heuristic function. In this, the function fn is equal to gn. Here fn is basically, you can say this is the evaluation function to select the node for the expansion, which I'm going to expand, which path is I'm going to expand, and gn is the cost function, or the cost from the initial state to the current state. So basically I am taking up this equation to solve my algorithm, or to solve the problem which are related to best first search. So I'll explaining you with the help of example. So this is basically the algorithm which is used in the best first search. Step 1, from step 1 to step 7, that means placing the starting node in the open list, and in the open list if it is empty, then stop and return the failure. Remove the node from open list and which is having the lowest value, and it is placed in the closed list. Then expanding the node n and generate the successors of the nodes. Step 5 will be check each successors of the node and find either the node is goal node or not. If any successor of a node is a goal node, then return success and terminate the search. As proceed to the next step, which says that the algorithm check for the evaluation function and then check if the node has been either open or in the closed list. If the node is not in both the list, then it is not in the, then add it on into the open list, and if not, return to step 2, that means iteration will be done. So this will be easily understandable with the help of example. So I'm going to take this example here. So there is a tree and having some kind of nodes, some arcs are there, and these arc is indicating a number, and this number is basically the cost of S to A, like nodes to nodes. So these are basically indicating me the cost. That means you can also say that this is basically your GN here. This is basically your GN here, and here the nodes is a table is given in which the node is having some kind of HN value, and this HN values basically can be calculated with the help of all the previous knowledge, like Euclidean distance, if it is falling in a straight line distance, if it is falling in a line of vision, so it can be a Euclidean distance, or if they are going vertically or diagonally or sideways, you can use Manhattan distance. So this HN is prior calculated and we need not to calculate it again. So the question is, now I'm having a this tree or a search, and I have to reach from S to G, that means source to the goal, where I have given in some kind of GN and I have also given some kind of HN in this. So I have to iterate and expand using the evaluation function, where Fn is equal to HN. Mind it, this is HN, not GN. That means if my search says that Fn is equal to GN, that means I have to consider this GN for searching from S to G. But if it is saying that Fn is equal to Hn, that means I have to ignore all these Gn and I will consider only the Hn part. So that is why I'm considering this thing. Now, if I'm going to solve this problem, then what will happen? See, if I want to move from S, so there are two successors, that means this time S will be kept in the open list, and further when it is going to in the closed list, then his successors A and B will be entered into the open list. And in this way, A and B both have some HN value. That means HN means basically the node. If I'm taking A, so that means the value of A to G, that means reaching from A to G, that is having some kind of value. That means this path is having a value of 12. And if I'm talking about S to B, then this path is having a value of 4. So out of both these paths, it can be easily calculated that this path is having the lowest value. So that is why I'll choose with this path. Then in B, it is also having some kind of successors with it. Then B to G, E and B to F. Now E to G is having some value like 8. Here F having value 2. So out of these two, this is minimum. So I'll choose with this path. F is further having their successors in the form of I and G. So I is having a value of Hn, that is 9, and G is value having 0. So I'll choose with this path. So certainly you will choose a path like S to B, B to F, and F to G. So this is how you can say this search is the best search. That means at the particular moment, what thing you are finding the best is, you are taking that path at that particular time. So this is basically what about BFS. Then this is the formulation, how this problem is being solved, that is being solved here. So this is basically the formulation, and this is how you can represent the nodes in the form of open and the closed list, and the path is here again S to B, B to F, and F to G. So if I'm talking about the properties of the algorithm, it basically says the time complexity and the space complexity of this algorithm is basically big O B raised to power M, where B is the branching factor and M is the depth of that particular tree, and it is said to be in the form of, yeah, in the property of completeness, greedy best search is also an incomplete search, because even if you are finding the solution, but still you are not able to guarantee that this problem can be solved or not, or you can solve this state space in a finite number of time. And in case of optimality, greedy best search is not optimal, because it guarantees to give you, again, it is going to guarantee to give you the good solution but not the best one. So that is why it is not fulfilling the factors of optimality here. So further, I'll use the refined form of this search, that is in the form of A star algorithm. So I'll try to explain it in the next slide. So basically you can solve this example that is also used solved by the help of BFS. Here the thing that needs to be reminded is, here Fn is equal to Gn. So that means I don't need any kind of Hn. Here Gn will be required, and Gn is given here in with a green pen. Here S is a source node and I here is a destination node, which is double rounded. So you have to reach from S to I using the value of Gn. So try to find out the path using the BFS algorithm here. So try to find it yourself. Then the next is your advantage and disadvantage of this algorithm. So because this algorithm uses the property of BFS and DFS over here, so basically it switch between BFS and DFS, so it gains both the functionalities, or it gains the advantages of both the algorithm. This algorithm is more efficient than BFS and DFS, because combinedly it is using the features of both the algorithms, so it is more efficient than that. In case of disadvantage, you can say that it can behave like an unguided depth first search in the worst case scenario. It can also stuck in loops as DFS is stucking up, and the algorithm is not optimal at the end, because there could be some another better solution, or another path could be available, but it only search with the path that is having the minimum value at a time of Gn. So for this, we need a refinement in this algorithm, that is in the form of A star. So basically A star algorithm is the most commonly known form of best first search, or the refined form of best first search, you can say. It combines the features of greedy best search as well as the UCS. UCS here is the uniform cost search. Uniform cost search says that I'll choose the path that is having the minimum amount of cost, and greedy best search says that the path that will be chosen with the help of Gn or Hn. So basically it combinedly uses a feature of UCS and greedy best search, by which it solves the problem more efficiently than the best first search. So it finds the shortest path, as the previous algorithm is also saying, through the search spaces using the heuristic function. So basically this algorithm expands the less search tree and provides the optimal result, and it will be more faster. So this algorithm is very similar to UCS, but here it uses Gn plus Hn as a whole, or the combination of both, to take instead of Gn only. Because in the previous algorithm, I am having like Fn is equal to Gn in the best first, but here Fn will be calculated on the basis of Gn as well as Hn. That means in that case, either you are considering this Gn and you are considering only the Hn. That means one of the factor is missing in this search, that is best first search, but here you are not going to miss anything. You are taking both the factors simultaneously, that is Gn and Hn value. So this is basically this algorithm is widely used in various domains for pathfinding and optimization problems, and the various application is in the robotics, video games, route planning, logistics. In robotics, it helps the robot to navigate the obstacles and find the optimal path. So basically I've discussed that here Fn is equal to Gn plus Hn, where again this is a function to be calculated. This means the path, and this is the cost of the path, and this is the Hn value, that means from that node to the particular goal node. So this is basically how this algorithm works upon. So this uses the search heuristic as well as the cost to reach to the node. Hence, we combine both the cost factors, and then we will going to formulate the answer for this algorithm. So basically, these are the steps. Here again also, their search space is given, either a tree or a graph will be given to you, and it is having some kind of nodes. Again, there will be two lists, that is open and closed list, and again the same concept is there, that you are going to take up with the initial node in the open list. Then further, if you want to succeed, then you will choose that particular starting node into the closed list, and you will take all the successors into the open list. Further, you will choose one of the successor, and then it will again rotationally do the work as it is in the best first search. That means you will place the starting node in the open list, check if that list is open, again the list is empty, then return failure. Select the node which is in open list and having the smallest value of G and N. If the node is a goal node, then return success and stop. Otherwise, expand the search and generate all its successors into the closed list. And further, for each successor, check whether this n is already in the open or the closed list. If not, then compute the evaluation function and place it in the open list. Else, if not, if it is already in the open and the closed list, then you should go with the back pointer, and which reflects the lowest value of Gn and return to step 2. This algorithm can be easily understandable when I am taking this example with the help of example. So here in this example, I have to traverse from my source to the destination, and here source is this and goal node is this. So using the help of A-star algorithm, I am using some kind of heuristic value, and in which Fn is equal to Gn plus Hn. That means I have to choose between, I don't have to choose between Gn and Hn. Instead, I have to use the computation of both. That means I need to consider this also and I need to consider this also. So I'll try to solve this problem to make you understand this thing. So this is the problem I've taken up here. So this is a source node, this is a goal node. So while solving this problem, first of all, I have to decide that which is my goal node and which is my starting node. So initially when I'm starting, so I can say this is my S. S is my starting node. From starting node, there are two possible combination or successors to be there, that is A and that is G. If I have to choose between both, then I have to calculate the Fn, and Fn will be calculated with the help of Hn as well as Gn. So that means if I say that my Gn is this 1 and my Hn, that means A to G path is 3, that means this makes a sum of 4. That means Fn value is 4 over here. And in case of G, that means my Gn is 10 and G to G is 0. That means here the Fn is equal to 10. So out of 4 and 10, as 4 is lesser, so I'll choose with this path. Then expanding my search, this A is having some successors in the form of B as well as C. Then calculating this, Gn is equal to 2 and B to G is 4, that is 6. So Fn is equal to 6 here. And in case of C, C is 1, 1 plus 2, that is 3. I'll go with this path, yani A to C. Then choosing with C, I'll check the successors of it, that is D and G. Calculating the Fn value for D and G means C to D is 3 and Hn value of D to G is 6, that means 9. And for G, the value is C to G is 4 plus 0, that means 4. So in this case, 9 out of 9 and 4 is lesser. So I'll choose with this path. So that in that case, the path will be S to A, A to C and C to G. And this is how A-star algorithm works, and this is how it is the try to finding out the optimal solution on the basis of not only the Gn but also considering the computation of both Gn plus Hn. So this is basically the problem formulation solution. So initially S is there, S is having some Hn value, that is Fn value, that is 5. Then A and G is further explored, that I have told you that this is 4 and 10, out of this 4 will be chosen, and then A is further explored, and the path here again comes out to be A to S, S to C and C to G, and this is the path which is providing me the optimal path with the cost of 6. So here all the paths are considered, and in this I have found this path to be the optimal because it is giving me the the lowest cost 6. So this is why it is considering the function of UCS. That means it is giving me the minimum cost of the path, as well as it is considering the greedy search also. That means it is considering GN value and HN value also. So this turns out to be good algorithm or best algorithm in comparison of the best first algorithm. So this is basically how I solved this. Then again, you can go with this example, you can solve this example on your own, and you can answer me in the comment box that what will be the path. Here S is the start node and G is the goal node. So I have to use the A star algorithm. I have to use both the GN as well as the HN. Here all the integer values are basically the GNs, and all the floating point values are basically the HN. So there is no any other table. All the information is given in the tree itself. You have to reach out to from S to G and try to find out which path will be the optimal using A star algorithm. So try to find it out yourself. So finally, you can say what are the disadvantages and advantages of this algorithm. So basically, A star algorithm is found to be a best algorithm in comparison of other search algorithms. A star algorithm is optimal and complete. It is used to solve very complex problem. The disadvantage of this algorithm could be like it produces short path. It does not always produce the shortest path, as it is mostly based on the heuristic and the approximation, because it is basically dependent upon the heuristic and the approximation value. If the heuristic and the approximation value is not accurate, so there will be very difficult to find the search your solution with the help of A star, because if heuristic is not updated, that the answer will be not updated. So this will be a disadvantage for that. The second disadvantage could be the memory requirement, as it keeps all the generated nodes in the memory. So it is not practically possible for various large scale problem. If the if the problem is having a large scale, so there could be a disadvantage in this. And finally, some points to remember about this algorithm is it returns the path which occurred first, and it does not search for the remaining path. The efficiency of A star algorithm is best in comparison of best first search, but still it depends upon the quality of heuristic, the accuracy of heuristic required to be more accurate, so that you will get the accurate solution in that space. A star algorithm expand all the nodes which satisfy the condition of Fn, that is Gn plus Hn. In case of following the properties of an algorithm, so basically we can say that A star algorithm found to be complete as long as the branching factor is finite. That means if I am finite a number of branches, and the cost of every function, every action should be fixed in that case. That means if I'm talking about the paths, so there must be some cost associated with each path. So those path costs should be fixed in the beginning. You cannot vary those costs according to time or time to time, because it can mislead the search and it can mislead the solution as well. In case of optimality, it is proven to be optimal as if it's follow the admissible and the consistent heuristic. In case of time and space complexity, this algorithm is again having big O b raised to power d, where again b is the branching factor and d is the depth of the tree that I'm going to search. So basically this is all about, I can say, about informed searches. Thank you.